This video is about reflecting function equations and graphs. So, the actions we're talking about is reflecting about the x-axis, about the y-axis. So you might want to think about what that means. What would it look like? Well, the shape should somehow be down here. What would it mean to reflect about the y-axis? What's over here would be over here. So you'd have something like that. Okay, so how do you do something with the equation f of x? Well, the y-axis, the x-axis, right? Things above and below the x-axis, that has entirely to do with the output. So this has to do with the output. So we need to do something on the outside of the equation. Well, we want positive values to now be negative values. So what do? Put in the same input as we had before, get the same output, but reverse the sign. So positive numbers are negative, negative numbers are now positive. How do we go about reflecting about the y-axis? Well, reflecting about the y-axis makes negative inputs positive and positive inputs now negative. So that has to do with inputs, and so it's going to have something to do with the inside of the equation. So f of negative x should be exactly what we're looking for here. Let's just follow a quick example with what happens if you put in negative f of x here. If you put in negative f of x here, well, 0 is still 0, 1 is now negative 1, and 4 is negative 4. So what happens there? What happened was this graph got reflected about the x-axis. Okay, on the flip side, what would happen if we put a negative sign in here? So it's now negative x. If negative x is negative 1, then f of negative x is 0. Well, that's all well and good, but our chart doesn't actually start with an x value. So we should start with an x value. If x is what, then negative x is negative 1. Well, if x is 1, then negative x is negative 1. This would be the chart that would correspond to a reflection around the y-axis. So I'll go ahead and plot those points in green. That is a reflection around the y-axis of the original curve. Now it's pretty easy to go ahead and do that with any old equation, just as long as you keep track of what you're doing. So reflect about x-axis, that's negative h of t, or negative 2t squared minus 1 minus the square root of 2t. Pretty easy. Could you distribute the negative? Absolutely, but you don't have to. That's the correct answer as is. You could also do something like reflect about the y-axis and shift up by 2. First, I'm supposed to reflect around the y-axis, so that's h of negative t. Now, when there's a then, you need to do this part, then you need to do that. On the very outside of everything, add 2. You can run into trouble if you don't follow these directions in order. Okay, so what does that actually come out to? A negative t as the input is going to be 2 over, you can write negative t squared minus 1, or since negative t times negative t is just t squared, you actually could write nothing changed there, minus the square root of 2 times negative t. Then after all of that, I have to add 2. Now you might say, oh gee, I've got a negative under the square root. That means that this isn't defined. It's not defined. It's just defined on a different domain. can you see that if you had just the piece y equals the square root of x, the domain would be the non-negative numbers. Y equals the square root of negative x, it's not that it's not defined, it's just defined for the non-positive numbers. So when you see this, don't think, oh, that's not defined. Think, oh, that's only defined for t values that are not positive. So that's just an aside. Okay, last but not least, I want to look at a function graph. I chose a sort of a funky one just so you could see how you do this process in general. Of course, you could do it with a quadratic or a cubic or anything else. Okay, so let's reflect about the y-axis. You could see that if you basically took this out, cut this piece out of the board, and flipped it around, that's exactly what it would look like. So let's just do one last one. Let's say we reflect about the x-axis, then shift up 2. Okay, now the order is really important here. Okay, I'm going to show you the intermediate step here. In fact, maybe I'll do the intermediate step in red to indicate that it is not finished. Okay, reflect about the x-axis. That's what it just looks like to reflect it around the x-axis. Now I'm going to shift it up by 2. So there you have it. The green line is the graph of the function reflected about the x-axis and shifted up by 2.